Good morning, students.
Good morning, ma'am.
Good morning, ma'am.
Good morning. Any queries related to binomial distribution? Today we will see another distribution, that is discrete distribution, that is Poisson distribution. Compared to binomial distribution, this is full of exponentiation formulas. We will go little bit slow. Anybody can tell me the definition of binomial distribution? Go through Poisson distribution, go through from your, go through, read Poisson distribution. Read Poisson distribution. Go through 1 minute. Go through the lines once. Right now listen. Poisson distribution. Poisson distribution was derived in the year 1837 by a French mathematician, Simon Denis Poisson. Poisson distribution was derived in the year 1837 by a French mathematician, okay, Simon Denis Poisson. Okay, Poisson distribution as a limiting case of binomial distribution. Poisson distribution as a limiting case of binomial distribution under the following conditions. Under the following conditions. Every distribution is having certain assumptions. If you remember, binomial distribution is also having certain assumptions. What are those assumptions? First assumption is the number of trials are finite and fixed. Second one is the number of trials are independent. The third assumption is it consists of mutually exclusive events, that is dichotomous classification. The other one is x always follows, random variable always follows binomial distribution with the parameters n and p. Mean of the binomial distribution is np. Variance of the binomial distribution is npq. All those are the assumptions. Based on the assumptions, we got mean value is np, mean formula is np, variance formula is npq, where n represents number of trials, p represent probability of success, q represent probability of failure. Here, Poisson distribution as a limiting case of binomial distribution. Okay, there we told the number of trials are independent. If you remember the three approaches of probability, we have studied three approaches. First one is mathematical probability. If you remember the formula of mathematical probability, probability of the event E or A, whatever it is you want to denote it. What we wrote, the formula is favorable number of cases, that is how many favorable number of cases and favorable number of cases upon capital N. We have considered population. If you want to consider sample, it is represented by small n, if you remember. Favorable number of cases upon exhaustive number of cases. Okay, what is the demerit in this probability, mathematical probability? When the number of trials are infinitely large, then we are unable to perform this. For that purpose, we have introduced a statistical probability, that is say limit n tends to infinity m upon n, small n or capital, whatever it is, it differs. Correct? Then first assumption, Poisson distribution as a limiting case of binomial distribution. First one is the number of trials is indefinitely large. The first condition is n tends to infinity. The second condition is the probability of success for each trial is indefinitely small. That is p tends to 0. Third one is mean of the binomial distribution is equal to mean. What is mean? NP. Here in some textbooks it is given as lambda or mu. These are again parameters for Poisson distribution. Under these three conditions, Poisson distribution as a limiting case of binomial distribution. Whatever the probability mass function of binomial distribution is NCX, p to the power of x, q to the power of n minus x. If you remember, x lying from 0 to n. And where n is finite. That's why binomial distribution is a discrete distribution. Then again, Poisson distribution was discovered by French mathematician Simon Denis Poisson. It was introduced in the year 1837 under the following conditions. The first condition is the number of trials are indefinitely large, that is n tends to infinity. Second one, the probability of success in each trial is indefinitely small, that's why p tends to 0. Here, third one, mean of the binomial distribution is np is equal to mean of the Poisson distribution, that is lambda. In some textbooks it is given as lambda, in some textbooks it is given as mu, in some textbooks it is given as m. Okay? Then how we have defined binomial distribution? Similarly, we will define Poisson distribution. How we have defined binomial distribution? A random variable x assumes only non-negative values and its probability mass function is given by p of x is equal to ncx, p to the power of x, q to the power of n minus x. Similarly, here how to define Poisson distribution? A random variable x assumes only positive values and its probability mass function is given by probability mass function. If you remember what we wrote, x is equal to x, simply we are writing as probability of x. Okay, here probability of x is equal to exponentiation to the power of minus lambda e to the power of minus lambda into lambda power x upon x factorial. Again, the probability mass function, you want to represent this way, you can represent, otherwise simply we will take probability of x. The formula for Poisson distribution is e to the power of minus lambda exponentiation to the power of parameter. Already I wrote here, just to go through these lines. These lines. Okay. E to the power of minus lambda. I told you in some textbooks lambda is nothing but mean number of successes. In some textbooks it is given as mu. In some textbooks it is given as lambda. In some textbooks it is given as m. Better to represent instead of mu, we will represent lambda. Why I am suggesting lambda? Why not mu? In third chapter we are having again queuing theory. Queuing theory, that is arrival rate. In queuing theory, if it is single server and single machine, single queue and single server, then arrival rate follows Poisson distribution with mean rate lambda. Exponential distribution is a continuous distribution that follows mean rate mu. Then if I take here instead of lambda, if I take mu, then in queuing theory we have to compare mu with mu. That becomes difficult. That's why instead of taking mu, better to take lambda. Otherwise, your wish. Okay, again, the probability, you have to remember these formulas, okay? Probability of x, it is entirely based on, it is a big derivation. We don't want, okay, how we got probability mass function of a Poisson distribution. Nobody is going to ask. Okay, here Poisson distribution is based on Erlang gamma distribution that you don't require also. For that purpose, Erlang gamma distribution is represented by the letter lambda. For that, simply you have to remember exponentiation to the power of mean number of successes into mean number of successes whole to the power of random variable upon random variable factor. Take down this formula, everybody. The mass function of Poisson distribution is e power minus lambda, lambda power x upon x factorial. That is enough for us. Then we will go through the problems. Go through the first problem, students. Go through the first problem. In binomial distribution, simply we have represented x running from 0, 1, 2 and so on. And here we will simply represent x is equal to 0, 1, 2 and so on. If it is finite, we will take the finite number of values. Here also, one more thing we are having. What property we have studied in binomial distribution? The assignment probabilities are permissible. That is p plus q is equal to 1. If you remember this. Here also, summation. There what we wrote? Summation I running from 0 to n. Probability of x is equal to 1. Here also same. Summation probability of x is equal to 1. Here also the same property applicable. The assignment probabilities are permissible. Or the other way, the total probability is always unity. Here also same condition applies. Summation, whatever the variable you want to take. Summation, I running from 0 to n or whatever it is you want to take. Okay, in general 0, 1, 2 and so on we will take. Probability of x is equal to 1. That is probability of xi is equal to 1. Then go through the first problem, everybody. And if you go through this, what I wrote here, mean of the distribution is equal to mu, variance of the distribution is equal to mu. That means here, instead of mu, what we are representing it as lambda. Mean of the Poisson distribution is lambda. Only for this distribution, mean and variance is equal. That's why this is a special distribution. Mean of the binomial distribution is lambda. Variance of the binomial distribution is lambda, because we are representing these with the lambdas. If you want to replace with mu, you can write. Okay, first one we will see. In a certain factory, it was found that the variance of number of absentees is 4 workers per shift. Find the probability that on a given shift, exactly 2 workers will be absent. Exactly 2 workers will be absent. Okay, here clearly they mentioned variance of absentees per shift. That means what is given? Variance of absentees per shift. That means what is given? Lambda value is given as 4. Lambda value is given as 4. Then here we need to find out first one, probability of exactly 2 workers will be absent. That means how we will write the mass function, that is probability of, correct? Probability of number of absentees in a shift. Probability of number of absentees in a shift. This is nothing but what? This is nothing but the mass function. This is nothing but probability mass function. How we will define probability mass function of Poisson distribution? E to the power of minus lambda into lambda power x upon x factorial. E to the power of minus lambda into lambda to the power of x upon x factorial. Students, I have sent a Poisson distribution table. Poisson distribution PCCOE WhatsApp group I have sent. Check it out.
Yes, ma'am.
वो टेबल देखना पड़ेगा हम लोगों को. सब लोगों के पास है ना टेबल? WhatsApp group में I have sent.
Yes, ma'am.
Poisson distribution table everybody is having right now. Then you have to go through that. First one is exactly 2 workers will be absent. What does it mean? X value is given as 2. X value is given as 2. Here, substitute the value. E to the power of, according to the problem, lambda value is minus 4 into lambda value is 4. X value is 2. Because exactly 2 workers absent. That is 4 whole square upon x factorial. That is 2 factorial. Then e to the power of minus 4. Right now go through the table. I will explain how to see. Go through the table everybody. Here appendix B I have sent. Okay, in that last table, 2 rows table you have to see. M values is given as well as e to the power of minus m values is given. That means e to the power of minus 4 value we have to see from the table. E to the power of minus 4 value we have to see. The value is 0.01832. Small table you have to go through. M values is given 1 to 10 and downwards e to the power of minus m values are given. But here what value we have to see? E to the power of minus 4. Okay, wherever m is 4, you have to see exactly the value. The value is how much? 0.181832. This value is 0.01832 into 4 whole square, that is 16 upon 2 factorial is 2 into 1. 2 ones are 2 eights are. Just multiply the value with whatever the value you are having, multiply with 8. Then you will get this value as 0.1464. Getting the same value?
Yes, ma'am.
Listen carefully. Previous years means whenever this was there in 2008 and 2012 pattern, later this was not, the syllabus Poisson, binomial and normal distribution was not there in DS. After 2012 pattern, they removed. But again, they have introduced because most of the companies are using Poisson distribution as well as normal distribution. That's why practical exposure should be required. For that purpose, again, they have introduced in decision science. Okay? Then, unfortunately, they don't provide this value. If I provide the value in the problem itself, here I wrote use Poisson distribution. That means I am giving hint in the exam. Okay, the problem is of Poisson distribution. But actual scenario, you have to identify whether the given distribution is Poisson or binomial. After reading the sentence, the student have to identify. For that purpose, nowadays they were not giving the values. They will provide 32 pages of statistical booklet they will provide. University will provide 32 pages statistical booklet. Among those 32 pages, you have to identify where Poisson distribution is. According to that, you have to write down this value. Okay, the table, whatever I will tell you exactly among those 32 pages, Poisson distribution lies in which page as well as normal distribution lies in which page, I will tell you before the exam. Okay, this table you have to see. Clear? If the value is not provided in the given problem, then you have to search in the statistical table. Before going to the exam, I will tell you in statistical table, 32 pages statistical table, which page consists of Poisson distribution and which page consists of normal distribution. Okay, clear? Because right now I have provided, immediately we are seeing the value and we are substituting it. Then go to the second bit. Any query, students? You have to remember the mass function, that's all for Poisson distribution. Then every day before go to bed, write down the formulas. Okay, next. Exactly 2 workers over. Second one is at least 2 workers will be absent. At least 2. That is x greater than or equal to 2. You know the formula. What is the formula? Probability of x greater than or equal to a is equal to 1 minus probability of x less than a. Correct? Probability of x greater than or equal to 2 is equal to what we have to write? 1 minus probability of x less than 2. What is probability of x less than 2? X is equal to 0. X is equal to 1. This is equal to 1 minus probability of x is equal to 0 plus probability of x is equal to 1. Right now, substitute the values. 1 minus, substitute in the value. Okay, you know the mass function. Here it is there. Simply substitute, lambda value remains the same. Lambda value cannot be changed. E to the power of minus 4 into lambda whole to the power of 0 upon 0 factorial plus, right now substitute x is equal to 1. E to the power of minus 4 value remains as it is. Lambda whole to the power of 1 upon 1 factorial. Right now, if you see carefully here, in both the cases e to the power of minus 4 is common. If you want to take common, take it out. Otherwise, already we know the value e to the power of minus 4 value, you know that. What is the value? That is 0.0183, correct? 183 into lambda 4 whole to the power of 0 upon 0 factorial plus 0.0183 4 whole to the power of 1 upon 1 factorial. Okay, something to the power of 0, 1 upon 0 factorial also it becomes 1. 1 upon 1 into 0.183. This is equal to 1 minus, right now expand the brackets. Here we will get 4 whole to the power of 0 is equal to 1. 0 factorial is always equal to 1. But most of the students used to write 0 factorial is 0. No, 0 factorial is 1. Remember. Plus, okay, then minus into plus, minus we will write down directly. Okay, 0.0183 into 4. Multiply that value into 4. Whatever the value you will get, you write down. What value you will get? 4 3s are 12, 4 8s are 32, 33, 4 1s are 4, 0. Okay, add these two values and subtract from 1. And subtract from 1. You will get this value as 0.9085. Verify. Are you getting the same answer or not? Getting same answer, students?
Ma'am.
Okay, good. Shall we go for third problem? Shall we go for third one? That is third bit. Not more than 2 workers. Can you tell me the answer? Not more than 2 absentees. That is vice versa. Probability of x less than or equal to 2. Today also, Kshitija, can you send me the attendance only for today?
Okay, ma'am.
Then, probability of not more than 2 absentees. That is probability of x less than or equal to 2. Probability of x less than or equal to 2. What does it mean? Probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. Okay. Right now, you know the mass function substitute. Okay, what is mass function? Every day before go to bed, please write down all the formulas, otherwise final examination jumbling of all formulas. Okay, here you know that lambda value is -4, e to the power of -4. Directly I am substituting. Lambda value is 4, 4 whole to the power of 0 upon 0 factorial plus e to the power of -4 into 4 whole to the power of 1 upon 1 factorial plus e power -4 into 4 whole square upon 2 factorial. Okay, the other way also we can do it this problem. Your calculations, everywhere e to the power of -4 is common. Take that value common. Here in brackets 4 whole to the power of 0 upon 0 factorial. I told it is 1. 4 whole to the power of 1 upon 1 factorial, that is 4 itself. 4 whole square 16, 16 upon 2, it is 8. Right now you know the value of e to the power of -4 value. What is that? That is 0.0183 into 13. Into 13. You will get this value as 0.2379. 0.2379. Any queries, students, in this? Next. Simply here they asked variance is given. Listen carefully. Variance is given. That means variance is represented by the letter lambda or mu. We are taking lambda because in QE theory there should be no confusion. For that purpose we are taking here lambda only. Okay, don't get scared. E power minus mu, e power minus lambda, e power minus m represent the same exponentiation function of the mean number of success only. Okay, here lambda value is given. Then you have to remember the probability mass function, because I am not giving binomial distribution, ma'am. How probability mass function has come? You have explained. Why don't this? Okay, this is a big derivation. Okay, you should know the formulas of e to the power of x. I don't have any problem. You should know the formula of e to the power of -x. All these formulas, that is not required. Instead of doing the big derivation, better to remember this formula. That's why I skipped that. If you want, I will take it. Okay. Then simply exponentiation. The meaning of this is exponentiation to the power of mean number of successes into mean number of successes of the random variable upon random variable factor. Okay, that is the probability mass function of a Poisson distribution. Okay, after that lambda value is given. That means e to the power of -4 remains constant throughout the problem. First question they asked exactly 2 workers. That means probability of x is equal to 2 is asked. Then substitute x value 2 in the formula. Then you will get first bit. Similarly, at least 2 workers. That means probability of x greater than or equal to 2. The third question what they asked, probability of not more than 2 absentees. That means x less than or equal to 2. Then calculate. Okay, from the table you will know the values. From the table you will know the values. Second problem, try it out. Just read and identify the values, because only 1 minute time is remaining. Go through the second bit. At least we will identify the values. The average number of major storms in your city is 2 per year. That means lambda value is given as 2. Next, what is the probability that exactly 3 storms will hit your city next year? Poisson distribution, like in BRM, we studied the regression coefficient is used for prediction. For that purpose, we call it as independent and dependent variables. There are two variables. Y is equal to a plus bx is the equation. आप लोगों को पढ़ाया नहीं है शायद, I don't know. Y is equal to a plus bx. Here, x is called as independent variable. Y